there are different ways that we can do it. There are different tools and support available from Microsoft where we can quickly move from our on-premises system and move to cloud. So this is called as lift and shift. Okay, so this is something from a cloud perspective. Again, a little background about cloud. Now we will slowly move into the data engineering world and we will talk about different types of data. So the next couple of things that we have is all about data. Now before I move into data, and I'll again take a quick pause to check if you have any questions.
We are good, sir.
Okay, no worries. Thank you. So now let's talk about the data types. Again, it will be a bit of a refresher for most of you. So what are the different data types that we have? So typically when we work in a data engineering world, we have, I won't say two, this is a bit wrong. We have three types of data. One is a structured data, then we have the semi-structured data, and then we have the no structured data. So what is a structured data? Structured data we have all seen where it's essentially nothing but a two-dimensional model where we have a table. So in that table, we have a row and we have columns. Each column will have a row associated with. Typical example is a SQL server, SQL database, a CSV file, all these things we call as a structured data, where we have all the data stored in a table. So before we create a system, we have to create a structure of the data. Now how the data is going to look, so we have to create a structure or the schema beforehand. And if you're working in a relational database system, then how do we store our data and how do we create the relationship between them? So this is something that we call as a structured data. Now when we talk about semi-structured data and non-structured data, in semi-structured data we do have a structure but it's not fixed. So for an example, a JSON file. So in a JSON file you will have a value and a pair. So you will have the key and under that you will have values. So they do have a structure to follow but it's not fixed. So for an example, if I have to create a comparison between a structured data and a semi-structured data, how would I compare is, if you create a table. Now let's take an example that there is a customer, so his customer ID is 1, and if I think from an address perspective, maybe this customer has 2 address, so he owns or she owns 2 houses. So how do we store it in a structured table? We cannot have 2 entries for the same record. So what we have to do is we have to create a different approach where we can have one row specifying address 1, another row specifying address 2. Now that creates a lot of problems. So whenever we create a typical RDBMS, we have to think about the uniqueness of the data, the key concept and all these things. So we cannot have duplicates. So how do we set up all these things? So that creates a problem. But in case of a semi-structured or a no structured data, it's pretty easy. The reason is that since they store the data in a key value pair, so we can have one key, under that we can have multiple values. We can say that my customer ID is 1, I have address 1 this, and another tag I will have address 2. So that's pretty easy to store in a no structured data. Now in a traditional SQL based world, we typically use TSQL or transact structure query language, which we use to interact with our data as a query language. But in case of semi-structured data, we typically store the data in Cosmos DB or HBase or any other storage, and we use something that we call as NoSQL. Feedback folks, NoSQL is something that stands for not just SQL. There are a lot of NoSQL data stores which also has support for SQL. Now there are of course a lot of benefits of storing your data in a semi-structured or in a no structured way. You don't have to create a relationship beforehand. You can store the data in a raw format. All these things are there. Since we don't have to create a relationship beforehand, so we save a lot of time in the data modeling, and typically we use NoSQL when we are dealing with a big data set, because relational systems are not designed to handle very high volume of data. And what is an exact non-structured data? These are something which doesn't have any data. Microsoft typically calls it as free flow text. When you work in Azure environment, you will hear that Microsoft calls no structured data as free flow text. That means that it doesn't have any shape, any size, any format. Think of an audio file. think of a video file. Of course, they have a format. I mean, maybe an MP3 or an MP4, but they don't have a structure. But still, we can analyze. We can do audio analysis, we can do video analysis, and all these things. Now, when we store, NoSQL, there are typically four types of NoSQL storage that we have. Again, we'll have demo on all of them. Key value store, where we store the data in a key value pair in a tabular structure. A typical example would be your JSON. Then we have document database, where all of these JSON files are stored in a native format. So there is no transformation, there is no relationship. It's just EL, extract and load. A typical example would be Azure Cosmos DB. Then we have graph database. So this is a very specific and a niche database that we have, where the data is stored in a graphical format. So I'll give you an example. What is a graph database? Think of it like this. Whenever we go for a graph database, we'll go for a graph database when we have a self-reference data store. This is something, think of it like this, that maybe there is a school. So in that school, there is a principal, then there are different teachers in that school. So there is science teacher, there is maths teacher, and all these different teachers. Now principal is the top, so the science teacher reports to the principal, the maths teacher also reports to the principal. Now then there are different labs, so there are different lab attendants. So one lab attendant reports to math teacher, maybe that same lab attendant reports to the physics teacher as well. And whenever the performance cycle comes, the performance is completely done by the principal. So you can see that there are a lot of self-reference and there are relations which are repeated. So whenever you have this kind of things, then we go for a graph database. Now if you look for graph database, Neo4j is by far the biggest graph database that we have, but Microsoft has enabled support for graph database also inside SQL. Very basic level, but it's still available. And then we have column database, which we call as column store or column based databases, where the data is stored in a columnar fashion. I'm not going to go too much of detail about the columnar data store. When we move to different storages in Azure, I'm going to show you a demo on that, and I will. So these are the typical storages that we have when we think about the data type. Now we will move details in Azure. Now we see that we have data coming in different format: structured, semi-structured, and no structure. Now since we're working on Azure, what is the storage that we're going to use and in which use case we're going to use these storages? Okay, so let's think about the Azure storages. Azure storage or storage is an essential concept in any project or application that you work. Anything that you do, you need to store your. Now Azure storage is something that we call as a storage account. A storage account is essentially a one-stop shop where you can have four types of stores. Now you can use these four types of store, or you can use only one type of store, but you have to create a storage account. Once you create a storage account, Microsoft will provision these four types of storage. Azure Blob. Blob stands for binary large object. As the name suggests, here you can store any type of data. It doesn't require shape, size, format, anything. It's essentially a binary object, so you can store any data. Then you have Azure Files. So this is nothing but an SMB protocol based file storage. Then you have Azure Queue. So Azure Queue is something, people who have worked in MSMQ, the Microsoft managed queue, this is the same version in Azure, which is called as Azure Queue. So it's a queue store. And then we have Azure Table. This is a NoSQL store for your no schema storage of structured data. So this is a specific type of storage, Azure Table, where we store the data in a tabular structure, but it doesn't require any schema. It's a NoSQL based store, so you can easily deal with high volume of data. A typical example would be, let's say that you're storing a log. So you have an IoT sensor. That IoT sensor is generating log. So of course you have a structure for your log. You know that what all things will be logged, but this is a very high volume of data. So in this cases, when we need a structured data but in a very high volume, a typical SQL is not able to solve this purpose, then we go for a NoSQL store which can store structured data. Then we go for Azure Table. Okay, now of course we are not just limited to this. We can provision different technology store like data lake store, HD inside, or you can use Azure storage also. Now How does Microsoft store the data is that this again is based on your SLA or the agreement with Microsoft. Microsoft will either store the data in a hard disk or they will store it in a solid state drive. So based on the plan that you have taken, of course, you can understand SSD, if you store, your performance will be better, but this will be considered as a premium storage. If you go for a standard storage, they will store it in a magnetic disk or in a hard disk.